All right, so this is our geometry test 1 through 85 review. This will probably be video 1 of I don't know how many. Hopefully we can get it done in 3 or 4 videos. I think there's about 34 questions here. Most of these questions we've seen before, right? That's kind of how Saxon works. We end up testing back over a bunch of stuff that we've seen before. But a lot of these questions are questions that people tend to get wrong. If a parallelogram FGHI is a rhombus, but it's not a square, which of the following is true? So what I'm going to do is I'm going to draw a rhombus that is not a square. Because all squares are rhombuses, but not all rhombuses are squares. Does that make sense? So there's certain things that I know about a rhombus. Let's start off here. F, G, H, and I. Okay, what do you know about a rhombus? Anybody? What do you know about a rhombus? Two sides are the same? More than that. You're on the right track. All squares are rhombuses, so what do we know about the sides? All sides are congruent, right? But that's not enough to prove that it's not a square, right? Well, I mean, yeah, opposite sides are going to be equal, but all sides are going to be equal. I think what you might mean is that opposite angles are congruent, right? So something like that. But that doesn't necessarily prove that it's not a square, right? Because opposite angles in a square are all congruent, correct? All right. What we're looking for in this question is that in a rhombus, okay, the diagonals are perpendicular. Okay, and that's what's going to keep it. It can be a rhombus with perpendicular diagonals without making it a square. Okay, so what we're looking for here is FH is perpendicular to GI. If F was equal to G, then they would both have to be right angles, and if they were both right angles, that would make all of them right angles, and that would force it to be a square. Okay, if measure angle I was a right angle, then it would force all the other angles to be right angles, and it would force it to be a square, right? If FG was equal to, let's see, if FH was equal to GI, then it would make it a rectangle, and a rhombus that is a rectangle is a square. All right, does this make sense? So the only one that allows it to be a rhombus without forcing it to be something more than a rhombus is A. Okay? All right. All right, let's look at question number 2. Identify the pairs of congruent angles and proportional corresponding side lengths. So we'll look at this in relation to angles and sides. Okay, let me hit. All right, so it wants us, let's start over. It wants us to identify pairs of congruent angles. Okay, pairs of congruent angles. All right, so can anybody give me 2 angles that are congruent? Angle D is congruent to angle, what did you say, B? Good. Okay. Angle, somebody give me another pair. Mariah, can you give me a pair? Yeah. Let's keep, yeah, angle F is congruent to angle A. Good. Minor. Angle E and angle C. Okay, great. Now we want proportional corresponding sides. Okay, so we're going to keep proportional. Okay. All right. So now we want proportional sides. So we're going to look at these sides. I'm not necessarily worried about the numbers, just the sides. So let's say, let's put them all over. Let's do like AC. AC is to what? We've got AC to what over here? What's that? FE. Okay? AC to FE is going to be proportional to, okay, give me another set. If we've done AC, what's another side on this upper triangle? CB, okay? Okay, what corresponds to CB on the lower triangle? What's that? Well, if we did CB, then we need to do ED. Does that make sense? Okay. And then finally, what's the last side on my upper triangle? No. Well, you said BA. Yeah, okay, BA. Okay, BA to what? DF. Because look, if you're at B, then you're at 1 tick mark, right? Okay, then we need to be at D, 1 tick mark. If we're going to A, 0 tick marks, or even 3, then we're going to go to F. All right, so we're going to keep those things. What's the answer at the bottom? Let's see if we're on the right track here. It may be different than what we had, but hopefully we have the same general effect. I'll even, let's scroll on down there. We're number 2. Okay, let's look at number 2. All right, so we got all that. They did EF to AC. Notice that they flipped it, but it's the same thing, right? They did DF to AB, same thing. They did DE to CB, same thing. The only thing that we had left to do there is actually write out the proportion. It's a little tricky to scroll there and get it matched up again. All right, so if we were writing out the proportion here, let's see. If we did BA.
This is a final all call for high school SBLA members. Please come to the gym whether you are dressed up or not. Thank you.
We would do 12/9, which would be 4/3. Theirs was 3/4, but that's because they had it flipped around, okay, which is fine, okay, because they didn't tell us which way to put it. All right, does that make sense? I feel pretty good about that, hopefully. Okay. All right, so we'll clear that out. All right, let's come over here to number 3. Identify the chords in the circle, in circle L. What is a chord? How do I identify a chord? It's a line segment that what? We're looking at a circle that has line segments. Can we show me or tell me what a chord might be in here? Go ahead. Line MO. Okay? Line MO. What do we notice about line MO? It goes from one side. Its endpoints are on the circle. All right? So anything that includes point L is going to be wrong. Okay? Because L is not on the circle. It's in the center of the circle. So we should have chord MO. We should have chord QO, chord QM, and chord PN. So I have 1, 2, 3, 4 chords that I should be able to identify, right? Okay? I always think about it kind of like a guitar, as the strings come across that center hole in an acoustic guitar. Granted, it's not a perfect illustration, but that's just kind of how I imagine it. Okay? All right. Let's clear that down, come down to number 4. Okay, position a right triangle with legs. Let's see, with leg lengths R and 2s plus 4 in the coordinate plane, and give the coordinates of each vertex. So this looks like a pretty hard question, right? So there's more than one way to kind of do this. All right, so here's our coordinate plane. And it says we want to position a leg with lengths R. All right, so let's say I'm going to do it just like this. Okay, right triangle. So I'm going to say that this is r. That's a length r. And this is 2s plus 4 lengths, right? You see what I'm getting at? So this coordinate right here, because we're talking about x length, but it's not going up or down, then the x coordinate there is r. And the y coordinate is what? 0. Okay? Up here, it's going straight up, but it's not going left or right at all. So what is the x coordinate here? 0. What's the y coordinate? How far up is it going? No, look, it's abstract, it's algebraic. How far up is it going? This one went r to the right, and so we said r was my x coordinate, correct? How far is this going up? 2s plus 4. So what is the y coordinate? 2s plus 4. Okay? So it says find the coordinates of each vertex, and so that means I've got one other vertex, which is 0, 0, right? Somebody check the bottom, right? We could have done this the other way. We could have said this is 2s plus 4, 0, and this is 0r. That's another way to look at it. We could have put it down here. We could have put it over here, down here. All right, we could have put it in a number of different quadrants. What was the answer? That's all their answer is? Okay, my guess is that on this question, that this was originally designed to be a multiple choice question. Whenever I took the multiple choice options out, right, it didn't know how to handle it, so it just kind of freaked out and left the answer as a multiple choice answer. But this, do we understand how to look at this? Okay. All right, let's come down here. Let's look at number 5. Looks like we've got a proof. It says write an indirect proof that an obtuse triangle does not have a right angle. Okay, so this is going to be based upon the fact that all triangles have 180 degrees, right? So if I have an obtuse angle, can I also have a right angle? What is an obtuse angle? It's an angle that is greater than 90 degrees, right? And a right angle is an angle that is 90 degrees. So let's say an obtuse angle was 91 degrees. What's 90 plus 91? What's 90 plus 91? What? What's 90 plus 91? 181 degrees. Is that greater than 180 degrees? Yeah, so by definition, can I have an obtuse angle and a right angle in the same triangle? Yeah, and that doesn't even give me a third angle, right? Okay, so we're going to look at this. It says measure angle S is greater than 90 degrees. So what we would say here is that that is the definition of an obtuse angle. Okay, does that make sense? Okay, you come down through here, measure angle R plus measure angle S plus measure angle T equals 180 degrees. Some of the interior angles of a triangle are 180 degrees. Okay, what they end up doing from here is, because it says in here, let S be the obtuse, let R be the right. So what they do is they substitute 90 degrees in for angle R. So what they do is, so now 90 plus measure angle S plus measure angle T equals 180 degrees. Substitution 90 for measure angle R. Okay. What they end up doing from here is, I got to take a look at it. It looks like what they do is they subtract measure angle T and 90 degrees over to the other side, leaving S by itself. Okay, so it's just subtraction. So we have measure angle S equals 90 degrees minus measure angle T. Okay, so then what they do is they substitute, looks like what they do, hold on, let me see there. They say 90 degrees minus measure angle T. Let's see here. Okay, we don't have a multiple choice option there. I'm trying to figure out what they did. It looks like they substituted in 90 degrees for measure angle S. They said that measure angle S was greater than 90 degrees. So 90 degrees would have to be, it has to be less than 90 minus measure angle t. Go down to the bottom and see what the answer is there, and I'll see if I can do a better job of explaining it. Question number 5. Okay, that's their part for number 2. Okay, so that makes sense. Substitution property of inequality, not of equality, because we're not dealing with an equal sign, right? And so once we have that, right, what we would want to do if we were trying to solve for measure angle t is we'd want to probably divide by 90, which is 0, and then, subtract 90 to the other side. So we're getting 0. We should get 0 is less than negative measure angle t. So we would divide by that. Let's see, what does it say? Add measure angle t minus 90 to both sides. Okay, so if they're doing that, if you're adding measure angle t minus 90 to both sides, looks like you should add measure angle t and subtract 90. What's it say on 3?
Measure angle t is greater than 0.
Yep. Okay. Yeah, because that would flip the sign. If we add measure angle t to the other side and subtract 90, that's going to leave 0 over here. We would get measure angle t is greater than, because the sign flips, greater than 0. Oh, it should be less than 0? Well, yeah, that would make sense. It would have to be less than 0. Okay, and so what they're doing is they're indirectly proving that it cannot be, because you can't have an angle that's less than 90 degrees. Or less than 0 degrees. All right, kind of bungled that. All right, let's go on to number 6. Find the values of x and y. Express your answers in radical form. You've got a 30, 60, 90 triangle here, so we need to use our 30, 60, 90 ratios. What is 30 in relation to the hypotenuse? What would I do to the hypotenuse to find that side opposite of 30? What would I do to 24? All right. Let me, hopefully, I'm going to draw a better triangle than that. Okay. So let's say this is our right triangle. This is 30, 60, and 90. What should this be? May you remember? Well, let's start off, let's call it x, right? Because it's always the first thing. What about the hypotenuse? What is it? Should be 2x, right? It is the side opposite 30 times 2, okay? And over here is the side opposite 30 times radical 3, okay? So if I have 24 here, what would I do to find x? Divide by 2. So what's 24 divided by 2? So x equals 12. So if x is 12, what's y? 12 radical 3. Okay? So I would try to remember that right there. Okay? Now, if they gave me a number here, a number opposite is 60, and I wanted to find x, I would divide by radical 3 to get that. Okay? If they gave me x and I wanted to find those other things, I would multiply it by 2 to find the hypotenuse, multiply by radical 3 to find the side opposite of 60. Okay? Aren't you glad you went? Okay. All right, number 7. Number 7. You guys want to open up, get your Chromebooks out so you can be looking at these documents, probably writing some things down. If a can is 43 inches tall, has a radius of 10 inches, how many cubic inches of water can the can hold? What shape is a can? Cylinder. If we're talking about how much water something can hold, what are we talking about? Volume. How do I find the volume of a cylinder? Find the area of the base and multiply it all the way up to the top. So all the way up to the top is represented as what? Height. So how do I find the area of the base of a cylinder? What's the formula for that? So we should have a formula of pi r squared times height. So in ours, we've got pi. Looks like we've got a radius of 10. So 10 squared times 43. So that's 100 times 43. That would be 4,300 pi, right? Okay. Plug that in your calculator. What do you get? They kept it in terms of pi. Was it 4,300 pi? Okay, so they kept it that way. I wish they would say that in there. If they don't say on the test, I'll accept either answer. Okay? So 4,300 pi inches cubed. Inches cubed is important because we're talking about volume. All right, number 8. Is this a reflection, a rotation, a translation, or none of them? So reflection. All right, if I need to, there's my line of reflection. Everything is perpendicular across, same distance apart on either side. So it's a line of reflection. Or sorry, it is reflection. Okay. Well, let's scroll on up here to number 9. Find RS. Okay, there's 2 ways to do this. There's a longer mathematical way and there's a fairly simple way. I don't care which one you necessarily do, so long as you get to the right answer. If I was going to do this really quick, I would take 26 minus 22. I would get 4. I would take 22 minus 4 and get 18. Just like that. Because the difference between my mid-segment and my longer base is going to be the same difference between my mid-segment and my upper base. But my upper base is going to be that same amount shorter than my mid-segment, as my mid-segment is from my longer base. Okay? The full formula form of this would be like this. I don't know what, we don't know what this is, so we'll call it x. X plus 26 divided by 2 equals 22. Multiplied by 2 on both sides. X plus 26 equals 44. Subtract 26. What's 44 minus 26? Probably 18. Okay? So you look at that, if you know what you're doing, that's not a lot harder to do. You should be able to do either method. Okay? Question? No? All right. All right, number 10. Circle A has a radius of 9. B has a radius of 4. CD is a common tangent. Hint, draw a perpendicular line. Okay, so we know that this line is 9. We know that this line is 4, which means I've got a line here of 13. They tell me to draw a perpendicular line there, giving me a right triangle, because what we want to do is we want to find CD.
Members of the band, color guard, choir, and high school band. Middle school, high school band, both honor guard and choir. Please report to the gym for pictures at this time. Thank you.
Austin, you're flags, aren't you? Okay. Okay, well, we'll see you guys. That way everybody on the YouTube knows. Okay? All class is clapping for you. You guys are brave. Okay? All right. So the thing about this perpendicular line that we drew is that it's going to be congruent to CD, which is why we're going to solve for it. Okay? If we can find the length of our perpendicular line, then we'll know what CD is. Does that make sense? Okay. So we know that we've got a hypotenuse of 13, but we have to have another leg. What we do know is that this whole length is 9, but this was 4. So can anybody tell me what this length should be, even though it doesn't necessarily look like it? 5. Okay, so 9 minus 4 is 5. So what we have is a right triangle where one leg is 5 and the hypotenuse is 13, and I want to find the other leg. What theorem or postulate would I use? Pythagorean theorem. So we should do 5 squared plus b squared equals 13 squared. We've got 25 plus b squared equals 169. Okay. Subtract 25 from both sides. I think that you'll find that b squared is going to equal something like 144. We'll square root both of those, and you'll find that b in this equals 12. So CD equals 12. Does that make sense? Okay. A lot of people miss that question. Okay, so you probably want to go back and watch that a couple of times, make sure that you understand the steps involved. Okay? All right. Let's come on down to number 11. Graph the equation. All right. So what is this equation showing me? What am I graphing ultimately there? Graph of a circle. Can you tell me what the center of the circle is going to be based upon that equation? 5, 3. Can anybody tell me what the radius is going to be based upon that equation? Is it 16 or it's 4? Because I have to square root it, right? So, just roughly, I'm going to go to the right 3, up 5. Okay, that's going to be the center. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, that should be my circle right there.